Now to get the equation for g of x, we ask if x is some value, then what formula gives us the value for g of x. So I'm going to pick this point on the g of x graph, which corresponds to this value of x here. Now this could be any point on the g of x graph, but I've picked one of the points that I actually constructed. Okay, if I'd have picked another point, let's say here, then I'd have had to draw the arrow there and show how that point was constructed from the f of x graph. Okay, so here is then the value of g of x. Okay, and I note that the value of g of x is the same as the value of f of x at this point here. Okay, so I say that's the same as the value of the f function here. Now that's not f of x. X is this right now. So f of x is up here. So I could say that, well, you know, of course here is f of x. That's f of x, it's not g of x, and it has nothing to do with g of x. So, what's the value of g of x? Compared to the value of the function f. Well, at this point, okay, this is x minus that horizontal displacement. So if the horizontal displacement is, let's say, h, so we're going to say let that horizontal displacement be h, so that this displacement here is h. Then, what are the coordinates of the, or what's the x coordinate of the point where f of x takes the same value, where the f function takes the value g of x? Okay, now what are the coordinates of this point? If this is x, what's the coordinate of this point? Well, it should be pretty clear that this point is x minus h, because if we add the displacement h to the x value here, we get this displacement. So we know that this displacement is h, so that this coordinate is x minus h. So that now we see that g of x equals the value of f at x minus h. So g of x equals f at x minus h. So g of x is f evaluated at x minus h. To get the value of g at a point x, you have to evaluate f at the point x minus h. Now the question is g of x a power function? I'm not going to address that just yet. But this is very important, and this is a hard transformation for people to understand. They can memorize the rule for a short time, but then they lose it and don't know how to recover it because they don't understand exactly what's going on here. So make sure we understand this. And hopefully you understood this previously and you were able to answer these questions, but that's a tricky question to think through. Not bad once you see the reasoning, but you want to say it's f of x plus h because everything's moving in h direction, but you moved from the f function to the g function. So you got to look back h units to find the value of the f function in order for the value of the f function to be here, to be the same as the value of the g function here. Okay, so that's one solution. That's a solution, not just a hint. Okay, the exponential function. Now hopefully you drew a graph of an exponential function. So let's just do that real quickly. I'm going to draw a graph here. And I'm going to assume some reasonable and I'm not real consistent about my length of these arrows, but we still get the idea. So we'll have some value of f here, we'll have half that value here, half that value here, double this value here, and double this value here, and double this value way up here. So we have this graph. Now if we apply some displacement, and I'm going to use a different color chalk, and the displacement will be clearly longer than any of these vectors. We're going to displace each of these vectors the same distance, so we're going to have something like this, and then what do we have to do? We have to come out to about here, and then probably didn't come out quite far enough there, but okay, we come out to here, and then from here we've got to come out to about here, and from here we've got to come maybe to here. So we have a series of points on this graph, and that one's probably off the edge, so that we can sketch. And I'm going to use something to contrast with the yellow chalk a little bit better to draw this graph. Okay, so here we have the graph of the shifted function. So this is, first of all, an exponential function, f of x. And now we have a g of x function. No, grabbed the wrong color. Okay, so we have g of x equals, just as before, it's f of x minus h. The reasoning is no different. Doesn't matter what the graph is. If you shift the f function h units in this direction, then the value of the g function is equal to the value of the f function h units back in this direction. Doesn't matter what f of x is. We can always say this. Okay, so now my question is this function exponential? Okay, so I want to look to see whether this function doubles every time we go through this displacement. So here we have a value, here we have a value. Is this value double this? And then from here to here we get this value. Is this value double this? And over here we have this value. Is this value double this value? If so, then the function is exponential. Okay, so and if it happens that it's not so, that doesn't mean that the function's not exponential. That would mean, okay, well, if each of these is double the previous, then we know that g of x is an exponential function with the same doubling displacement as the original. Now, if this doesn't quite work out to where it doubles, or doesn't work out at all, That doesn't mean there isn't some other doubling displacement for the new function. The new function might, as far as we know right now, have a different doubling displacement than the original. So there are really two questions. Is this function exponential? And if so, is it exponential with the same doubling displacement? We could also ask it, is it exponential? And is it exponential with the same doubling displacement? That's the first thing we'd probably check. And if not, is it exponential with some other doubling displacement? Now that's completely equivalent to the way I phrased the question previously, and you want to think through the logic of those statements to understand that. But the bottom line here is, can we prove that this function has to be exponential provided this one is?